Good morning, everyone. My name is Kira Proctor, and welcome to our fourth webinar of 2022. Our series of webinars have been running now since 2020, and if you've missed any, you can go back and review them all on demand right here on our YouTube channel. You can also catch up on our Learning Hub at www.proctorgroup.com, where you can book in for follow-ups with our team of experts around the country, access up-to-date information on our full range of products, or order product samples. Today's webinar is the second in our series of Toolbox Talks, focusing on installation and site practice, and we'll be looking at our Roofshield air and vapour permeable underlay membrane. We'll begin with an overview of Roofshield's purpose and performance, and some of the legislation and regulations that apply to roof underlays. We'll then run through some frequently asked installation questions and common situations found on site. Lastly, we'll finish up with our regular Q&A session, today featuring special guest Keith Soulsby, Operations Director at Northern Bear. The key to the high performance of Roofshield relative to most other vapour permeable membranes is its melt-blown core. This layer of microscopic fibres, many times narrower than a human hair, gives a microporous structure through which air and water vapour can pass easily, but liquid water cannot. This high-performance core layer is sandwiched between two robust and durable outer layers of spun-bond polypropylene, making the entire composite material lighter and more flexible than traditional roofing underlay felts, while still providing tough and durable secondary protection. The three-layer structure is open to the passage of both water vapour and air. So where most vapour-permeable underlays rely purely on diffusion to release moisture, a Roofshield roof also has substantial airflow through the roof voids, similar to a conventionally ventilated roof. This additional airflow helps prevent condensation by turbocharging the transfer of moisture vapour, greatly reducing the likelihood of moisture problems arising, even under the most extreme conditions. At the same time, the hydrophobic additives work to actively repel liquid water from the surface of the membrane. In all but the most extreme weather conditions, where an additional tarpaulin is recommended, this provides effective temporary protection to buildings during construction until the outer covering is in place. So, what is condensation and what causes it? Most everyday human activities such as cooking, cleaning and even just breathing generate moisture vapour, and this, combined with warmer indoor environmental conditions, causes what is known as vapour pressure, pushing this moisture outwards and into the building fabric. As we move through the fabric of the building, the temperature drops until it reaches the outside temperature. The warmer the air is, the more water vapour it can carry. So, as this temperature drops, at a certain point the air will become saturated and dump this vapour out as liquid water. This is called the dew point. This is the same effect that causes bathroom mirrors to steam up, or water droplets to form on cold drinks, and if it occurs within the building fabric, it can cause damage or mould growth. To make sure we keep this under control, we have to balance the design of the building and the materials we use, with both the purpose of the building and the weather conditions it is expected to face. A warmer and more humid building, like a swimming pool, in a cold climate represents a far higher risk of moisture problems than, say, a largely unoccupied warehouse, but somewhere warmer. So, we have to account for these factors when we are considering the materials and products used. At its simplest, we need to consider how heat, air and moisture move and interact within the building, and then ensure whatever is designed and built can cope with these conditions. The effects of all these are interlinked, so it's important to take an integrated or holistic view of these factors, rather than just looking at each one in isolation. How we do this is explained in BS 5250, the Code of Practice for the Management of Moisture within Buildings. BS 5250 defines the various types of construction membranes used in the management of moisture, and explains how they're used. It also covers other methods of moisture control, for example ventilation, and gives a detailed prescriptive guidance that covers most situations. BS 5250 is directly referenced in the building regulations for all areas of the UK and Ireland, so its guidance must be followed to meet regulation requirements. When it comes to roofing applications, BS 5250 details the ventilation requirements for two types of underlay. High resistance or HR underlays are impermeable membranes, which rely on ventilation alone to prevent condensation. Traditional roofing felts and its more modern plastic equivalents fall into this category. Low resistance or LR underlays allow the passage of moisture vapour. Therefore, the level of ventilation required to avoid problems can be reduced somewhat. It's important to remember that BS 5250 only provides generic guidance and outlines the minimum performance standards that are applicable. For roofing applications, this means that it does not include guidance for situations where all ventilation is removed. If a roof is to have no ventilation, BS 5250 refers to the use of third-party certification, such as a PBA certificate. Each certificate is specific to a particular product used in a specific application, and while a lot of certification outlines similar requirements, this cannot be guaranteed. If a product is changed, it's critical to ensure that the certification covering the replacement does not require different guidance to be followed. For example, minimum requirements for vapour control membranes or how well sealed the ceiling should be. Failure to install a product in accordance with its third-party certificate can lead not just to a failure to comply with BS 5250, hence the building regulations, but also to noticeable moisture problems, resulting in callbacks to sites and costly remediation works. These variations are particularly important when using air-permeable membranes like Roofshield in cold-pitched roofs. If these membranes allow enough airflow and are installed correctly, the additional benefits air permeability provides can greatly simplify the design and construction. Roofs with Roofshield do not require ventilation openings at the eaves, but also do not require openings at the ridge, regardless of the size, shape, or layout of the roof. This is particularly important for complex roof shapes or room-in-the-roof constructions, where getting airflow evenly distributed throughout all of the roof voids can be a problem. Omitting low-level ventilation also means loft insulation can be placed further into the eaves. This makes it far simpler to detail the junction between the roof and wall insulation, minimising heat loss in this area. As building regulations look for further lower U values, 400 to 500 mm of insulation may be needed at ceiling level. This makes ensuring a ventilation path at eaves even harder. The temptation is to pull back the insulation, but this could lead to what is known as a cold bridge at the ceiling level at eaves, which could lead to condensation and/or black mould on the ceiling. Ridge ventilation is also not required when used on NHBC projects, which typically require 5 mm ridge ventilation, even when a vapour permeable underlay is specified. This additional ventilation is required to ensure higher initial moisture loads from wet trades can dry out, but the higher moisture transfer of Roofshield's air permeable structure means that this isn't needed. As well as being simpler and cheaper, omitting this opening means the ridge of the roof is never open to the weather during construction, which, combined with the W1 weather tightness rating, allows Roofshield to provide temporary weather protection for up to 3 months. If particularly extreme weather is anticipated, however, it's good practice to add a tarpaulin for additional protection during such conditions, and the time the membrane is left exposed should be kept to a minimum. Another benefit of air-permeable membranes is in the sealing specification. The third-party specification for Roofshield allows it to be used without a vapour control layer at ceiling level, which may not be the case for other membranes. As we discussed earlier, every LR-type membrane allows vapour to escape the roof by diffusion, where the warmer internal conditions push the vapour out through the roof. If the underlay is both vapour and air permeable, however, the airflow through the roof boosts this effect substantially, which in turn lessens the additional measures required to avoid condensation. This means that using Roofshield on a project is subject to a lot less restrictions on applications or specific additional requirements than other types of vapour permeable underlays. So, whilst using Roofshield means no vents, no VCL and no problems, swapping it for another membrane without fully considering the implications on the design can lead to a failure to comply with building regulations and potential damage to the roof. We'll now move on to take a look at the practicalities of working with Roofshield on site. Our team have worked on projects of all sizes all over the world, so whatever your requirements are, it's unlikely to be something we haven't come across before. As we saw earlier in today's webinar, Roofshield is a 3-layer membrane with a unique spunbond and polypropylene core layer. This gives the material its vapour and air permeable structure. Because of the additional mechanism for vapour transfer provided by the airflow throughout the roof, condensation risks in the roof are greatly reduced. This means ventilation and vapour control requirements are far less stringent than with other types of roofing underlay, which do not allow the passage of air as well as vapour. Many years of expertise, testing and certification have shown this type of air and vapour permeable solution to be the simplest and most robust means of controlling condensation in roofing. Whilst Roofshield was designed to be installed similarly to a traditional felt underlay, just without ventilation, it's still important to ensure that Roofshield is detailed and installed correctly. So let's now run through some of the best practice procedures on site. Before starting an installation, it's important to make sure the rolls are correctly stored to prevent damage prior to installation. Rolls of Roofshield are supplied individually wrapped and with an enclosed installation reference guide. The rolls should be carefully stored under cover and on a clean, level surface. Care should be taken not to place rolls on top of anything that could potentially cause damage to the membrane, such as discarded nails or screws, as these may cause small punctures or scuff damage, which can be difficult to see during installation and potentially may lead to water ingress. Roofshield should also be protected from direct exposure to sunlight prior to being installed on the roof. It's also important to consider the weather forecast prior to installation, and if necessary, take appropriate precautions. High winds can make any work at height more difficult, and wet conditions may make the membrane surface more slippery. If particularly extreme conditions are expected prior to the installation of the outer roof covering, the use of additional temporary protection such as a tarpaulin is recommended. The BBE certification for Roofshield gives a maximum exposure time in the UK of 3 months. However, as with all temporary weather protection membranes, the period of exposure prior to the completion of the roof should be kept to a minimum, especially during periods of expected bad weather. The outer covering specified for use on the roof can also affect the installation in a number of ways. The air openness of the specified slate or tile probably has the largest effect. Certain types of roof finish may require additional ventilation to be provided into the batten cavity of the roof. Depending on the overall roof configuration, this may mean additional counterbattens are needed. The detailed requirements for when and how much ventilation is needed are given in the British Standard BS 5250 and 5534, the Codes of Practice for Moisture Management and Slating and Tiling respectively. What's important to remember though is that the entire roof system is considered as a whole at the design stage, so changes to any of the materials or requirements specified may have unintended effects on other parts of the system. If it's necessary to make changes to the design on site, the factors should be fully considered and any changes approved by the design team prior to commencing with the installation. Finally, the fixings used should be carefully considered. Whilst this may not seem a major consideration, round profile clout nails are typically a more robust fixing than narrower staples. Clout nails tend to stretch the fibres in the membrane rather than cutting them, leading to improved water penetration resistance and less likelihood of damage occurring in high winds. The resistance of the roof to wind uplift forces is another critical consideration, and the process for determining this is detailed in the BS 5534 standard. The standard mainly details fixing requirements for ridges and tile assemblies, with methods given to calculate how many nails or clips are required to fix the outer tiles in place. If these requirements are not correctly designed to resist wind uplift forces, then in extreme cases the tiles or slates of the outer covering can be damaged. This damage will be mainly caused by uplift forces, directly removing the slates or tiles by sucking them up and off the roof. But in theory, it could also occur due to the underlay membrane ballooning and pushing them off. Although there is little, if any, conclusive evidence of this occurring, the 5534 standard sets criteria for underlays to resist wind forces and divides the UK into 5 wind zones. This table gives the uplift resistance force for the Roofshield membrane for each installation configuration, along with the measures that must be taken when used in a given wind zone. These measures can include taping joints or using additional counterbattens. However, for NHBC projects, counterbattens are not acceptable for this purpose, and batten gauge should be reduced instead. The Scottish practice of slating directly into softwood sarking boards is acceptable in any wind zone, and in fact, wind resistance is precisely the reason this detail is traditionally used in the harsher Scots climate. It's worth highlighting, though, that the simplified approach given in this table is only suitable for roofs less than 15 metres in height and located on sites at less than 100 metres above sea level, where topography is not a significant factor. Out with this, the 5534 standard document should be consulted for more detailed guidance on how to address the wind uplift resistance. Horizontal laps required between runs of membrane vary slightly according to the pitch on the roof. This is to ensure that in addition to water running down off the roof, wind-driven rain cannot be blown back up through the horizontal laps, and these lap dimensions are the industry norms. In practice, the majority of roofs are between 15 and 34 degrees, so the 150 mm minimum lap size is marked on the Roofshield membrane. If, however, the roof is out with that pitch range, it's important to ensure installers are aware the lap width must be altered to accommodate this, particularly if the pitch is lower. Minimum roof pitch is dictated by the outer covering rather than the underlay, so if the outer covering can be used below 15 degrees, then so can Roofshield. Before moving on, we'll take a minute here to discuss the various types of pitched roof configuration commonly used in the UK. Firstly, we have cold pitched roofs, where the insulation is placed at ceiling level with a large cold loft space. In this type of roof, the insulation used is usually mineral fibre, as space is rarely an issue. Traditionally, these loft spaces are ventilated, with openings at the eaves and/or ridge to allow airflow, but modern LR membranes may allow this ventilation to be reduced or eliminated, as is the case with Roofshield. With roof insulation requirements increasing with each revision of the building regulations, ventilation paths may become an issue at the eaves, or the insulation could be pulled back, leaving cold bridging spots. As we saw earlier, air-permeable membranes like Roofshield are the least restricted in terms of conditions attached to non-ventilated use. A warm-pitched roof places the insulation along the slope of the roof, keeping the spaces with the roof warm. Typically, rigid insulation boards are used in this type of application, as space between rafters is more limited. There are less restrictions and conditions applied to membrane types in this roof configuration, and ventilation is less common provided a Type LR underlay is used. This is because the lack of large voids where moisture-laden air can accumulate reduces the condensation risk somewhat when compared to a cold roof construction. The third configuration is the room in the roof, common to many properties where an existing loft has been converted into habitable space. In this type of roof, there are a mix of cold and warm spaces, and this can make providing adequate ventilation across the whole roof difficult. Roofshield works very well in this type of roof, as it's used in a similar way across both cold and warm areas, and usually requires no ventilation or other special measures in either type of roof. This means it also works well when a roof is built as a cold roof, but with the provision made for loft conversion in the future. The type of roof configuration used has a bearing on how the membrane is installed, and specifically on how a drainage path under the tiling battens is ensured. In a cold roof where the membrane is unsupported, this is most commonly achieved by simply draping the membrane between the roof rafters, thus providing a gap for water to run off the roof. Too large a drape can cause problems with the membrane flapping or chattering in the wind, and whilst Roofshield doesn't tend to suffer from this problem, BS 5534 suggests 15 mm is the maximum underlays should be draped. This also helps reduce the risk of the membrane touching the underside of the tiles. At the other end of the scale, the minimum is not explicitly stated, but it can safely be assumed that a drape of between 5 and 15 mm is sufficient to permit drainage. This can easily be verified on site if necessary by simply pouring a bottle of water down the roof and ensuring it can run under the tiling battens. For warm and room and roof constructions, draping between the rafters can still be achieved if there is sufficient space available, and indeed this can be a good option in refurbishment where raising an existing roofline is not possible. In this type of build-up, it's perfectly fine to lay Roofshield directly onto the insulation, and no gap is required. Earlier generations of vapour permeable membranes could suffer from an effect known as tenting, where water would leak through if an underlay came into contact with insulation beneath. But this is more or less unheard of these days. Warm roofs do, however, require vapour diffusion to be controlled, for example by using insulation boards with a high vapour resistance. The rigid foams commonly used in warm roof constructions will usually meet this requirement. If the thickness of insulation specified does not allow the membrane to be draped sufficiently between the rafters, then counterbattens should be used to elevate the tile battens. The BBA certification for Roofshield specifies a minimum counterbatten depth of 12 mm. The membrane can be positioned either directly onto the rafter with counterbattens over the top, or the counterbattens can be fitted first and the membrane draped over them. This approach is the same if a sheet sarking material such as OSB or plywood, or if a continuous layer of over-rafter insulation is used, and again the membrane can go either under or over counterbattens. If this type of sarking is used on a cold roof, however, it's important to remember that ventilation to the loft space is required, as sheet sarking is not sufficiently permeable. In fact, this is one of the very few circumstances where ventilation is required below the underlay when using Roofshield. If the sarking used is softwood boarding, as is traditional Scottish slating practice, then ventilation is once again not required. The BBA certification defines this as being softwood planks nominally 150mm wide with 2mm gaps in between. In practice, the sarking boards are usually fitted relatively damp. Then, as they dry out, a degree of shrinkage occurs, giving plenty of spacing between adjacent boards. This shrinkage therefore provides the 2mm spacing referenced in the definition. So, we'll now move on to consider some common details: eaves, ridges, valleys, penetrations and verges. At the eaves, the most critical concern is ensuring the flow of water into the gutters is unimpeded. Although the Roofshield is a secondary weather protection, during construction or in the event of damage to the slates or tiles, drainage is critical. To ensure this works effectively, an eaves carrier is used, either of 5U roofing felt or a proprietary plastic system. The Roofshield should lap over this carrier by a minimum of 150mm and the carrier dressed into the guttering. This carrier not only ensures a smooth flow into the gutters for water running off, but it also helps ensure insulation fitted into the eaves does not press the underlay up against the battens, which would also impede drainage. It's important to take extra care to ensure insulation at the eaves is fitted tightly, but not so tightly as to restrict drainage. As well as checking insulation, any changes in level and positioning of the lower tiling battens could also drop the drainage pathways, and as such should be considered carefully prior to installation, and double-checked throughout and afterwards. At verges, the membrane should be turned sufficiently up at the abutting wall to ensure the flashing fully covers it to prevent water ingress. The outer flashing itself should extend above the tiles to ensure rainwater is kept on top of the outer roof covering. When rainwater lands on a surface, the majority of the splashes do not reach above 150mm or 6 inches, so this is usually considered the minimum spacing above a flat surface to which weather protection is required. That said, it's worth double-checking this requirement for the specific outer covering specified, as there may well be variations between different products and systems. On a dual pitch roof, the Roofshield is simply returned 150mm over each side, creating a robust weather-tight ridge to the roof with no openings required at any point. This lack of openings for ridge vents means the roof is wind and watertight sooner in the build process, and with no possibility of problems arising from failure to cut the underlay to allow airflow. This lack of ridge ventilation is also true for new build NHBC projects, where Roofshield's suitability for use without the usual 5mm ridge-only ventilation is now written directly into the BBA certificate. In a monopitched roof, the membrane is returned over the ridge board a minimum of 150mm. In this type of roof, a fully permeable underlay makes for a far simpler solution than providing ventilation, as it ensures moisture can escape from the entire roof, with less concern about dead spots where there is inadequate airflow. Where such roofs abut vertical walls, these areas are detailed in the same way as the verges discussed previously. Where it's necessary for a type or flue to penetrate through the underlay, an appropriately sized hole should be cut in the membrane, and a pipe of flue collar used. The collar should be sealed to the membrane surface using wrap-tight tape, bearing in mind it may be necessary to provide additional support below the membrane to ensure a proper seal can be made. Where boiler flues pass through the underlay, additional separation may be needed. There's an increased risk of softening and deformation of Roofshield where temperatures are above 70 degrees centigrade. So, if the expected service temperature of a flue is above this, advice from the supplier should be sought as to the spacing required. The final detail we'll consider is a valley. The first stage here is to lay additional battens either side of the low point to form the outline of a channel. The Roofshield is then dressed up and over these battens. This base of the channel is then formed using the Roofshield detailing strip, taken up over the battens either side so there's an unbroken strip of membrane down the low point of the valley. Finally, the permanent flashing strip is added, giving the valley its fully waterproof outer covering. Lastly, let's review some general considerations to be aware of when working with Roofshield. Although air permeable underlays are better able to deal with excessive moisture loads, for example from construction moisture during the drying out period, it's still important to ensure ventilation and extract systems are installed and functioning correctly. Of particular importance is making sure any ductwork running from fans through the roof spaces are properly connected and sealed. Similarly, any downlighters, particularly in wet rooms, should be sealed and convection tight to prevent excess moisture ingress. Ensuring the habitable spaces are sufficiently ventilated with correctly sized and installed trickle vents is another important part of ensuring good indoor air quality is maintained, as well as limiting moisture ingress to roofs. Lastly, loft hatches should be properly sealed and insulated. This not only limits moisture ingress, but it plays an important role in reducing heat loss from the building. So that brings us to the end of today's presentation, and we'll now move on to the Q&A session. Good morning, everyone. First of all, I hope everyone's doing well, and thank you very much for joining us on our webinar today. Believe it or not, this is our 51st webinar that we've been doing these since lockdown, and we now have over 100,000 views of all of our webinars. And this is actually the first one I have done from our offices. So after running around telling everyone to make sure they kept it down, it's really nice to be back here with a full office again, and we're getting back to normal. As you know, we will stay on and try and answer all of your questions, so please ask them either here on YouTube, email us at webinar@proctorgroup.com, or direct message us on Twitter. If you'd like to request a product sample pack containing the materials that were discussed in this webinar, you can do so on that page, and you can also book a meeting to discuss with one of our staff a particular project or get further information. Personalised CPD certification for today's webinar is also available at that same link, which is www.proctorgroup.com/webinar. A quick date for the diary before we go into the questions and answers. The Friday the 27th of May at 10 AM, and that will be protecting buildings on radon affected land. We'll have a special guest, Paul Colbeck, who's the chair of the British Verification Council, and he's also an expert on gas protection systems. So we'll be discussing radon protection guidance, risk assessment, as well as protective measures and installation guidance. If you've registered, you'll receive a follow-up email with all of these links and a link to the replay. And late registration is still open for this week's webinar if you would like, if you want the replay link. So this week we have some familiar faces. Technical Director Ian Fairnington. Morning, Ian. He's always a bit slow on a Friday.
Sorry. Morning, Kira. Morning, everybody.
Good morning. Business Development Manager Adam Salt.
Morning, everyone. Morning, Kira.
Morning. Our Regional Sales Manager Mark Blackie.
Morning, Kira. Good morning, everyone.
Morning. And we have a special guest who is the former managing director of Wensley Roofing, and current Group Operations Director of Northern Bear PLC, Keith Soulsby.
Thank you very much, Kira. Hi, everybody.
Hi, Keith. Nice to see you again.
And nice to see you again as well. Not so much nice to see Ian, but there you go.
So I'm just going to jump straight onto the questions. So bear with me because they're coming through on YouTube. We also have a lot of questions coming through on Twitter, and we've had some prior sent on email. So stay as long as you can, and we will just ask away and answer as many as we can. So Adam, if I can start with you, please. Amanda Warren has asked on YouTube, how long can I leave Roofshield exposed for?
Okay, that's a question we got quite a lot, especially during the lockdown periods. Yeah, so I think if we look at our BBA, Roofshield can be exposed, and when we talk about exposure, we're talking about to UV rays for up to 3 months, and that will cause no loss to its performance criteria. But it is important to point out that Roofshield and other membranes in pitched roof are a secondary layer to resist that liquid water that does expose behind the slates and tiles once they're installed. So it's not a primary covering. So if you know there's going to be persistent rainfall, heavy storms come in, then we would recommend you cover up and protect the membrane, but especially sort of winter months as well. But yeah, for UV rays, 3 months.
Thank you very much, Adam. Ian, Greg Robertson has asked, will the new revisions to Part L affect roofing underlays?
Yeah, That's a good question, Greg. It's one that we're starting to be asked quite a lot about the new regulations and what the effect would be on underlays. Certainly with the new regulation requirement, it looks like in cold roofs, you're going to be looking at 400 to 500 millimetres of insulation in the cold roof, which makes it particularly difficult. It was mentioned in the webinar, particularly difficult to put in the insulation when it comes to the eaves. So if you're ventilating that cold pitched roof, to create that airspace is going to be increasingly difficult. And again, in the webinar, it said that the temptation would be to pull the insulation back, so you've got that airspace, but that could in itself leave a cold bridge and potential condensation, dampness on the plasterboard. So as you would expect, our recommendation would be to use Roofshield, where you don't need to put the ventilation in at the eaves and fill those insulation right up into the eaves. And be careful to obviously close off the cavity, but insulate that ventilation right into the corner, which is a much better detail and, in our opinion, fail safe.
Mm.
Good. Thank you very much. And Ian, just while you're on and in the swing of things, Tapco Roofing Products have asked, is a counterbatten system needed for use with insufficiently air open roofing tiles?
That's another good question. A discussion I had earlier this week with a really good, in our opinion, really good roofing contractor in Northern Ireland, which we do require ventilation when it's Roofshield, where it's fibre cement type slates, and that's because of the outer covering not being permeable enough. And the discussion that we had was whether fibre cement was air open enough to allow that vapour that escapes through the Roofshield into that cavity to escape. Our recommendation is to ventilate that cavity. And that's not necessarily because of the Roofshield, it's because of the fibre cement or tight fitting tiles on the outside, which can lead to the tile curling. And therefore, those issues of curling of those outer covering were being blamed on the membrane rather than what could be argued as a failure of the outer covering, not liking moisture on the underside. I was told that the underside of the fibre cement is now treated that it can tolerate more moisture on the underside. But as things stand at the moment, we would recommend that you do have a ventilated space below that tight covering, and therefore the easiest way to do that is to put counterbattens on your roof.
Can I just make a comment there, Ian?
Yep.
Historically, when using fibre cement, before the advent of Roofshield, we used to get an issue with the fibre cement slates curling. So I couldn't see how it correlated to the use of Roofshield when it was happening prior to Roofshield. I just couldn't grasp that one, I'm afraid.
It's a great point that you're making, Keith. And what I was concerned about was that Roofshield was growing in popularity in those days, just exactly as you say. And the detractors from breather membranes in roofs were using that as an example of why breather membranes in roofs were a bad problem.
Mm-hmm.
So we took the decision, or I took the decision that, you know what, let's leave that market alone.
Mm.
Didn't want the problems being levied on Roofshield.
Yeah. And of course, we do the same with metal tiles with the batten gap as well. We get an airflow going underneath the metal tiles. In that case, it's not worth using the Roofshield, in all fairness. So you probably lost out on that, Mark.
Yeah. We can handle that one.
Yeah.
You can't win them all. So Keith, there was a question earlier on I missed actually from Marina Phillips, who's asked, is it better to install Roofshield above or below counterbattens when used?
Historically, Ciara, it depends in the country, to be fair. In the north here, we've always put the Roofshield underneath the counterbatten. Down south, I spoke to guys who prefer to put it on top. I can't say it makes much difference, to be fair. as long as we get a drape either way, we're fine. Drape's an interesting topic as well. I think in Scotland, Ian, am I right in thinking that the joiners who install the roof trusses, they actually put the membrane on up there?
Yeah, that's a very good point, Keith. In the north, it's part of the joiner's package when he's putting up the trusses, because I think probably because we do get a bit more rain up here, occasionally, allegedly.
Yeah.
So part of the joiner's package is to put the underlay when he puts the rafters on, so that it keeps the building wind and watertight. So a lot of the time the underlay will go on there before the roofing contractor even gets there.
The other thing to remember is if local knowledge is paramount with these kinds of things, and if you get if you got a job, a roof whereby it's 3 stories high, it's near the coast, it's going to be susceptible to heavy winds, then that's the other reason why I like to put it underneath, because of the alleged balloon effect that can happen with the membrane where it touches the back of the tiles. By having your counterbatten on, it gives you that little bit more security. So personally, I like to go underneath.
Okay, thank you very much. Mark, I haven't forgotten about you. Daniel has asked, is there a minimum batten spacing when using Roofshield?
Well, just following on from Keith's comments there, it very much depends on the location within the UK, because as you can imagine, there are different wind zones which affect batten spacing. But in BS 5534, there is a table which shows different wind zones across the UK. So in zones 1 to 3, anything equal to or under 345 mil batten spacing would be acceptable. And the same batten spacing can be used in zones 4 to 5, but will require, say, a wrap tight tape or a counter batten. But if you prefer not to use a counter batten or tape, then you'll just have to reduce the batten spacings to 250 mil. I should also point out that the batten spacings is also dependent on your relative tile gauge. So whatever tile you're using, you need to take that into consideration as well.
Of course, great. Thank you, Mark. Here's a good one for you, Adam, that James put on Twitter. How breathable is Roofshield?
That's a good one, actually, because I've got something to demonstrate that in a moment. I think the term breathable gets thrown around quite a lot. What we'll actually talk about, especially in roofing membranes, when we say breathable, is we normally mean vapor permeability. So Roofshield is one of the most vapor permeable membranes on the market, but it also has that benefit of being fully air permeable. So to demonstrate that from a sort of traditional airtight membrane in a bubbler here, water on top, resisting the water as you would expect from a membrane, but when we pump air into the bottom chamber, nothing's going to pass through the membrane. But on a membrane like Roofshield, same thing, resisting the water, but when we pump air into the bottom chamber, we should start to see the air passing through. So there's the benefits of Roofshield, and that's how it's allowed to take out the sort of high level ventilation and basically making the whole roof surface areas for the air to escape, rather than just focusing on where your ventilation systems are. If you want to know in terms of actual numbers, then Roofshield's got the vapor resistance of 0.065 meganewton seconds per gram, which in SD value is 0.013 meters, if that's what you prefer. But yeah, that's the answer in numbers.
Okay, thank you very much. And Adam, can I also ask you, is it correct that Alison had asked on at LinkedIn, actually, this one, is it correct that I do not need a vapor control layer when using Roofshield?
Yeah, so it's particularly in a cold roof assembly, then as long as you've got that sort of well-sealed ceiling, I think that's defined in the BS 5250, then Roofshield has the ability to remove your BCL. I think in our BBA for cold roofs, it's also stated that a BCL is not required under section 7.7. If you're doing a warm roof, however, then we would recommend a condensation risk analysis to be carried out, and then we can determine whether it's critical. In some cases, the VCL can be emitted, maybe even downgraded to a foil-back plasterboard, or even the foil-faced insulation boards, as long as they're taped on the joints. So there's certainly options with warm roofs as well as cold, but get in contact with those.
Thank you. Another one from Twitter. The Twitter ones are always interesting ones. Mark, I'll direct this to you, and then we'll come back to some of the others for Ian and Keith. Kenny has asked, is Roofshield expensive, Mark?
Yes. Roofshield is more expensive than traditional non-breather felt. However, what you can do is save costs when it comes to the total project cost. So one of the biggest cost savings is labour, as we alluded to, that Roofshield does not require any sort of ventilation to be installed. So you're also saving costs associated with the ventilation hardware. And just following on from Adam's point, there can be other cost savings to the project when the VCL is removed and in warm roof applications. Also as well, Roofshield doesn't require a 50mm ventilation gap between the membrane and the insulation, which allows you to fully fill the rafters. But if you do have a particular project in mind, we'd be happy to do some costing exercises between your current roofing system and a Roofshield system.
Mark, can I just add on that? When we introduced it here in the Northeast to some of our national house builders, one of the things which we saw the one did proved correct was they've all got these huge customer care divisions now. I'm talking about the national house builders, and it's saved them, the guys in that office, all the hassle they were getting from clients between sort of November and March, ringing up to say, I've got a condensation issue, And it certainly cut down from that point of view as well. So it's a sort of cost saving, if you know where I'm coming from.
Absolutely. I suppose what you're talking there is life cycle cost savings in terms of ongoing maintenance over 10, 15 years.
I wish I'd said that. I wish I'd said that, Mark.
Yeah, I guess the square meter price versus remediation costs are significant, and that's where we've seen a lot of success with the house builders. Keith, here's one around battens. Jeff has asked, is it detrimental if the battens are treated, e.g. tannalized? Yeah,
obviously preservative treatments is in all battens. We actually had an issue a number of years ago when we'd used, dare I say, one of your competitors' products, and we'd felt it and battened the roof. Not long after it started to rain, and the client complained there was water ingress. We couldn't understand why. When we went up, it was clear the water was just dripping through. It was like a tenting effect, although it wasn't tenting, where it was just dripping through. And we got the guys out from the manufacturers, and it was put across that this was the problem. The battens in those days had arrived, I think they were tannalized, I think they were, and it had leached into the product and had allowed the water to drip through. What they said was, and they were quite correct, over the next sort of week or so, it corrected itself, it reformed, the material reformed, and it was fine after that. But it is a problem, it can happen. The battens these days tend to be a lot drier when we get them. So is the problem going forward? Possibly not. But one thing I do know is that Roofshield does not suffer from that. We've never had one problem with that since we started using Roofshield. So, yeah, it can happen.
Good, thank you. Ian, a general one here. Phil said, can you drape Roofshield into the gutter?
Yeah, that was covered in the webinar as well. You can put Roofshield into the gutter.
No, you can't.
I'm looking at it, but we wouldn't recommend it. There's a number of reasons we wouldn't recommend it, but long term, it's as Adam said earlier, Roofshield is not a primary cover, so it's not expected to be left exposed. Some people, when we first launched Roofshield, did drape it into the gutter, and indeed one of the first projects we did non-ventilated locally, that must be near 20 years ago, did have that draped into the gutter, and I've since been tested it, and it's lost a bit of its strength, but it's still doing a function. But the best way, as we said in the webinar, is to use either a plastic support, which adds that bit more support than Roofshield would ever do, or use 5U felt to drape into the gutter. I love Roofshield, same as everybody else on this panel, but it's not great to see on the edge of the eaves. that green and white, although it's great to see on the majority of roofs, it's not great in that area where it's flapping about and the building's finished.
I think with the plastic tray as well, Ian, that gives the added support. Instead of using a sprocket behind the fascia board, it gives an added support to the membrane to stop the membrane from dipping as well. So it's twofold. It's better into the gut of the plastic support for the UV light, and it also gives the support to the membrane as well behind the fascia board.
Good. Ian, Jem has asked, metal sheet roofing appears to be becoming popular with new build dwellings and extensions. What would be the ventilation requirements when using Roofshield as the underlay?
As a general rule with metal tiles, we would say that you should ventilate that area because the metal tiles are closely fitted and they're just not allowing enough vapour to pass through it. So we would require an airspace there, probably provided by a counterbatten in that area.
Okay, good. Thank you very much. Ian, there's one that's coming here via email. Let me just find it. Sorry about this, guys. About the document. Oh, sorry. So does the ability of Roofshield allow airflow through it as well as water vapour offer any benefits to preventing overheating highlighted in the new approved document?
That's another really good question. Overheating is going to be a thing of the future, maybe more in the south than in Scotland. But I like the idea of, and I like the way the person's actually phrased that question, that this could help. So maybe we could have a discussion with them. We hadn't actually thought that the air permeability would stop the overheating, but it's a nice concept to think that it could. I'm not quite convinced because the insulation's obviously below it. The same way as air tightness, we take air tightness within the dwelling rather than the uninhabited space. But it's certainly an interesting concept that if we can take their name out, I would like to explore it further.
Okay, thank you very much. A few more questions coming here on YouTube. So Adam, perhaps I can come to you for this one. What are the key drivers for specifying wrap tight over Roofshield? I note the significant difference in price between the two products.
Okay, yeah, so I think Roofshield's got its sort of reputation for being a wall membrane. We see it quite a lot on sort of high-rise projects.
You mean wrap tight there? Sorry, Adam.
Sorry, wrap tight. Sorry, yeah. Gone on with that. Yeah. So, but wrap tight is a Class W1 membrane, so it can be used on the roof as well. Appropriate for sort of the fully supported systems. It's great for those projects where you're using wrap tight on the walls, maybe a sit panel house, and you're taking it. You can take a continuous airtight line onto your roof. And it just makes a better airtight seal and a better design having your whole building wrapped externally airtight. So yeah, if you have any of those projects, I mean, we can certainly have a look at those. But I think that the fact that wrap tight can also allow vapour to pass through makes it a good product for that type of application, really.
Yeah, I think it's a good point. I mean, when I built my own home, it was very, we built it to very low air tightness figures. It was a structural panel, wall and roof. So coming on to Chris's question here around what's better, wrap tight or Roofshield on a warm roof, it depends what you're trying to achieve. Certainly I was trying to achieve low air tightness throughout the whole structure, including the roof. So I used wrap tight on my entire building. And as you said, Adam, completely wrapped the entire structure, which as my dad pulled into my house was horrified not to see green on the roof, having worked with Roofshield for 25 years. So I think it depends on the objective. They both have different characteristics, and certainly depending what it is you want to achieve, it would be, you know, touch base with us directly, and we can certainly clarify with more information what you need. Okay, more questions. I've got so many coming in. I think we've got about another 5 or 6, so please feel free to keep asking. Keith, Sharon has asked, what drape would you recommend for the underlay?
Historically, we've had problems with drape under 5534, which obviously is the British standard, the code of practice at a certain time. They used to say around about, they used to say 25 mil, I think it was 25 million, I'm sure it was. But what we had issues with in the past, various court cases, believe it or not, because you had overzealous clients or clerk of works going up with a tape to measure what that drape actually was. And the drape's actually there to channel the water down the center of the membrane between the battens, down the center membrane, and then the gutter. That's what it's designed for, so it doesn't actually hit the nail holes where the battens are fixed onto the rafters, because that can obviously be a weak point, so we drape it. Ideally, personally, I like to see 10 mil. I think 10 mil is more than adequate to use for that. The maximum drape was so large that again, I touched on this before, the balloon effect that could occur, where if you put too big a drape on, with your negative wind pressures, we get the felt coming up and hitting the back of the tile, allegedly. I don't think this has been proved 100%. Ian and I often discuss this little bit. And I think by reducing that, you reduce that possibility as well of just having the 10 millimeter drape. So for me, 10 millimeter. There was a suggestion by someone that to see if it's working, the roofer could pour some water down the roof to make sure it's working. If you can get a roofer to pour water down a roof whilst he's working on the site, you'll be very, very lucky. So 10 millimeters is fine here, is what I'm trying to say.
Just when you bring up the ballooning fact there, we had an email in from Sam, and I'll direct this one to Ian, and then perhaps you can comment a little bit more.
Yeah.
Quite a dramatic one. So windstorm Eunice, what next? And what are the implications for underlays?
Well, that's a good one. The climate change, we're seeing more storms, but this wind uplift, as Keith just alluded to there, we have lots of discussions with other roofing contractors, and it can be proven in the lab that the underlay can touch the tiles. It can even be proven that the tiles could actually be flip off the roof. But I think that's kind of in a lab. When I went around good roofing contractors like Keith and others within the NFRC, I've still to find a roofing contractor that actually says that that's actually happened. And I'm still waiting for evidence. I've asked the committee for evidence. And unfortunately, I haven't seen any evidence. After every storm on a Monday morning, I'll send out an email asking, can you send me photographs? And it's just tumbleweed coming back. The only thing that comes back is I'm told that it's 1 in every 50 years storm that we're worried about, which is interesting because I had a roofing contractor on the phone from Ireland who's been in business for over 55 years, and he's not experienced it in the 1 in 50, and he's done the 1 in 50 as a practice. So I think we have to worry about potential climate change. We have to worry about storms. I think 5534 has really improved the way that roofs are the tiles are installed. The old practice of nailing every Thursday, tiles on, it just doesn't happen anymore. The roofing contractors have really upped their game. They install the tiles really well. I think it's a bit of a red herring. In a lab, it could be done, but we don't build in labs.
I think, Ian, the testing for it though was done on 345 gauge with a 600 center rafter. That's I was talking to Paul Blackmore at BRE about this. He was actually very interested to listen to about the possibility of ballooning, because that we then say if we have 450, I know it's not very often these days, most traditional build these days are 600 centers. Well, if we drop 450 or 400 old properties, there's no chance of any balloon when you get to there. Similarly, the work on 345 gauge. Well, 345 gauge is the maximum gauge for a large profile tile. How often do we put it on there? Not that often. Average rafter is around about 6 meters on a roof. Now, what you do, you divide your 345 into your 6 meters, it's how many courses you've got. So you normally end up with a 90 mil headlap rather than a 75 mil headlap, because you never go on your 345. And by virtue of the fact you're dropping your batten gauge down, again, that makes the balloon effect, it just won't happen. plain tiles, for instance, 100mm gauge, never going to happen in a month of Sundays. It's good, and it's another reason why I just think it's a fallacy, quite honestly. But hey, go.
That's why we really wanted you on this kind of committee. It's fair enough for me, Adam and Mark, to say it doesn't happen, but it's the real roofing contractors like yourself that it's really heartening to hear whether it's a problem or not.
Never had a problem with it, never in the past, never.
Oh, Tony's asked, can an excessive overlap be counterproductive? Is that something you can comment on?
Well, I think we quite like overlaps. If you want to extend the overlaps, then great. I'm sure Mark and Adam would agree with us there. Maybe not Keith.
No, definitely not too much money, Kira. Too much money in that Roofshield.
But you can extend it. I can't see it being a particular problem as such, compared with leaving an overhang that could flap up. So I don't think there's a problem.
Good. Mark, Graham has asked, what's the lowest pitch of roof I can install Roofshield onto?
Well, ideally, the lowest pitch is 12.5 degrees, but that is largely dependent on the outer covering. You've got to make sure that the outer covering is suitable for whatever level of pitch that the roof is at. It can be used on lower pitches, lower than 12.5, but that again is if the outer covering allows it, such as say an aluminium standing seam roof or a secret fix metal roof application where you don't have any lateral joints across the roof slope. So with that, the standard lap with Roofshield is 150mm, but when installing it below a pitch of 15 degrees, you'll need a minimum lap of 225. But on steeper pitches, you can install Roofshield at 100mm lap. So anything over 35 degrees or above.
Okay, thank you very much. Adam, sorry, a quick one I missed earlier. Do you know if we have AutoCAD details on our website?
Yes, I believe so.
Okay.
I think one of our marketing technical bods will put the link in the chat.
Okay, perfect. That would be wonderful. Thank you very much. Here's a very good one. This is something we talk about a lot from Andrew. Is there a problem for roosting bats hooking their claws into the fabric of Roofshield? Ian, perhaps you're best placed to discuss that. Something we talk about a lot in the business.
Yeah, you're absolutely right. We do talk about it a lot in the business. We have competitors that talk about having bat-friendly breather membranes. I would love to develop a bat-friendly breather membrane. Unfortunately, we find it difficult. The bats create the claw away at the underside of the underlay. If the breather membrane, which most of them are long continuous fibres, they'll eventually get tangled up in it. And we've done testing with Roofshield, not on bats, but on a simulation. I think it was the Isle of Wight that have testing facilities. And Roofshield performed better than all the other membranes. Now, you'd expect me to say that, but that's true. I was quite excited by that, but what it actually meant was that the bats would take longer to tangle up than the other membranes. So, whilst it was advantage to a certain extent that Roofshield would take longer to tangle the bats up, it still meant they got tangled up.
A slower death for the bats, so perhaps not very good at all.
Yeah, I think so. I mean, it's one I've felt, and I think one I've felt takes a bit of stick sometimes, or a bit of abuse. In this particular case, one I've felt does work well for bats, and we have recommended that you use one I've felt if you're concerned about bats, because the bats can't actually get themselves tangled up in it.
Yeah, we've done actually bat hotels, Ian, believe it or not. We did a bat hotel for a client, a local university, and that was all 1F. We've always used 1F when bats are involved.
Absolutely. I mean,
Yeah.
I think the other thing, which is probably more of a ham principles that proctors get involved in, bats don't actually like breather membranes. It's not like the old division where ventilation or no ventilation. It's because breather membranes, in particular Roofshield, obviously, it's too dry. So the environment is too dry. So even if we could allow them to not tangle themselves in the membrane, it's too dry and they wouldn't like it. So they would prefer a 1F felt because it's a bit more relative humidity in that loft space, and therefore they thrive more than they would in a Roofshield roof.
Yeah.
So unfortunately, we're not great news for bats at the moment.
Indeed. What I missed a little earlier, and I'm coming back to these. Craig had asked, can Roofshield be used directly underneath lead details such as valleys, gutters in place of normal lead underlays, such as a geotextile?
We've used it before under lead and with no issues.
Yeah.
We've had no hassle with it before. And to be fair, it's a breather. It's going to work.
Yeah. We actually supply, or we have looked at supplying it in 600 wide sizes, so that people are not going to have to take a 1 meter wide and cut it down.
Right. Yeah, good idea.
It was a Roofshield eaves detail, I think it was called, the rolls, so that these Roofshield didn't walk from the site. I think you've said before, Keith, that sometimes a part roll can sometimes walk.
Can disappear, yeah. It's only bugbear I've got the size of the rolls, as you know.
Yeah, we've got that eaves detail for that particular exact application.
Thank you. So coming to our last few questions, a quick one here from Mel. So what is the current practice with nailing tiles? How many nails per tile?
Nailing tiles. What type of tile do we know?
He hasn't specified. I don't know if there's a one fits all.
Well, first and foremost, all the roof tile manufacturers have a fixing specification, which is a recommended specification that they use. And for that, you've got to give various bits of information, like obviously where it's at in relation to perhaps the coast, on a postcode, height to the eaves, height to the ridge, the width of the building. It's a simple form you fill in online, and that would give the client the idea of how the roof tile manufacturer says his tiles, their tiles rather, should be fixed. Of course, nailing is fine, but invariably a clipping a tile is better because nailing holds down the head of the tile, whereas a clip holds down the tail of the tile. So if we have a tile nailed at the top, we have a fulcrum point for wind uplift. Whereas when we nail it at the bottom, then it holds the tail of the tile, which is far superior. However, they should go to the appropriate roof tile manufacturer and ask for guidance.
Okay, thank you. Ian, Judy said, do we need to use tape on the laps when fitting Roofshield?
I think Mark's dealt a lot with that already. He mentioned the wrap tight tape can be used on Roofshield, more in the high loaded areas, the zones 4 and 5, which is the sort of west coast of Scotland. As a general rule, I'm not a great fan of taping underlays. So zones 1 to 3, certainly I wouldn't recommend that we tape laps. It's okay if it's fully supported, but certainly to have the concept of actually downward pressure on an open rafter, I think from a health and safety point of view, is not great, especially if it's a 1.5 metre wide roll where you're overstretching potentially. So I'm not a fan of actually taping it, certainly with a double-sided tape on the underlay.
I know when I heard this was coming in with a new standard, I think I spoke to you, Ian, and said, you know, what's the situation with Roofshield? Because we're not fans of tape either, at least I'm not personally. It adds time to the job as well from a contractor's point of view. having to make sure it's there. You then run the risk of having a roof tiled and you haven't taped it down correctly, and the clerk of works come along saying, let's have the roof off because that tape's still loose. I don't like tape at all. So I was delighted when you decided it wasn't required, obviously.
Adam, Will has asked, will Roofshield get condensation during the drying out period?
Okay, so I'll start with sort of the drying out period and what that means. So when the project or the property's finished, complete, the moisture that's accumulated within that building starts to head out of the structure. Moisture will be generated from all the wet trades, so the concretes, the plasters, and etc. And then also when the occupants come in and start living as well. So that all moisture is trying to escape the building. And once it's complete, it's going to be the big period of where condensation might start forming. So it's critical, in that stage. So when the property starts to get heated, that first winter, we're going to start seeing that sort of vapor drive, and condensation is likely to occur on the back of a membrane. Now, it's important to note out that with Roofshield, it's far less prone to that effect, and that's mainly due to its air permeability. I think that's demonstrated with the bubblers earlier. And it's been proven on a number of projects in over the 25 years of us having Roofshield out in the market. So yeah, far less prone for it to happen with Roofshield compared to other types of membranes out there.
Thank you. Okay, we have one final question, which is a tweet for Keith the contractor. So we'll just call you that from now on, Keith. Do you have an underlay that you use for all work? And if not, how do you decide what to use?
Okay, well, obviously, we're sometimes forced to use different types of underlays on specifications. Our architect will specify a particular underlay that he thinks is suitable. Sometimes we get an architect specifying an underlay that he thinks does not require ventilation because the manufacturer may suggest that it doesn't. We have to approach the architect if we think it has, because we have a duty of care as a contractor to make sure what the membrane that they're putting on will perform. So we sometimes got to say to them, if it's a re-roofing project, for instance, the architect might come up with a membrane and say this doesn't require any ventilation. We have to remind them that it's perhaps a pre or post-war house that has no, as Adam referred to earlier, no VCL in the ceiling. So we've got to say, no, I'm sorry, but it definitely requires ventilation. So we have that. We then have the issues of the metal tiles, as we spoke earlier, and the fibre cement. There's no point in using, Roofshield on those products because we have to ventilate anyway. So there's no need to. So to answer your question, where we are able to specify ourselves, even for ordinary clients, one-off properties, we specify Roofshield at all times. I know that's what you want to hear from me, but it's true. We do have other membranes that we use when it's depicted that we have to use them, or where, as I say, when we have Eternities, did I say Eternities? Fibre cement or metal tiles, where we just use a standard membrane. So in answer to the question, where specified, we have to use certain products. Where it's our own choice, we use Roofshields.
Thank you very much, Keith. We appreciate your support. And I think it's fair to say you've given us a lot of insight into the market over the years. And, along with Ian, helped us see where the industry is going and regulations are going, and having someone that's on site doing the actual installation of the product that's close to us has been very helpful, along with a number of others. So if anyone's watching, thank you for your support. Okay, so that brings us to a close. I think I've managed to capture all the questions. If I've missed any, please pop them on email to me, and we'll make sure that someone in our technical or sales team comes back to you. So just to recap very quickly, another date for the diary, 27th of May, that's Friday the 27th of May at 10 a.m. Is our next webinar. It's protecting buildings on radon affected land, and we have a special guest, Paul Colbeck, who's the chair of the British Verification Council, and he's an expert on gas protection system validation. So during that webinar, we'll be discussing radon protection guidance, risk assessment, as well as protective measures and installation guidance. I just want to thank everyone for attending. If you can give us a thumbs up on our video or like our page, that would be great. We're now, where our subscribers are going up, and it also keeps you informed. If you've subscribed to our YouTube channel, keeps you informed about anything else that we're posting or doing that isn't necessarily a live webinar. After this, you will receive an email. It has a replay. Please feel free to circulate it. If you're employing people, to your staff, if they want to learn more about Roofshield, to anyone that you might think this would be of interest to, please share it far and wide. In that email, there will be a link to a short survey. If you have time, please fill it out. We read them. I read everyone personally, and we do use the information to help us shape future webinars and do things differently if we need to. So thank you very much, everybody. Have a wonderful weekend. Thanks to the panel. Keith, I can't thank you enough for joining us today. Thanks for your time, and have a great weekend.
Good.
Very much. Bye.